All right, I guess we can get started since we're at the top of the hour. So hello, welcome to everyone. Welcome to the afternoon part of our Saturday session. And this is the BI reporting and business use cases track. Now we will have a talk by Ryan Johnson of the title, Being Right Starts by Knowing You're Wrong, which I actually really like as a topic. So a little bit about Ryan. Let me introduce him. Ryan began working with data in graduate school where he studied glial cell arborization. Now that's a mouthful right there, in the brain. His PhD work was followed by a research fellowship with the Mind Institute at UC Davis, where he worked with MRI data from children with autism. Since moving to private industry, he has built and led business intelligence, data engineering, and data science teams for a variety of firms. And he's happy to be back to making a positive impact by helping with data efforts at the edtech company GoGuardian. So without further ado, Ryan, the virtual floor is yours. Take it away.
Great. Thank you very much, Cal. Okay, we tested this already, so everyone should be able to see my screen. I'm sure Cal or Mark will speak up if something's going wrong. Looks like it's working on my end.
Looks good.
Great. So let's get started. Yeah, the title of the talk, I owe that to a team member named Kevin Wecht, who saw the abstract and came up with a clever title for it that I really appreciate. But I guess what we're really going to be talking about here are some of the challenges on the path to becoming a more data-driven company, or really one of the challenges. So let's get to it. So the biggest challenges to implementing effective analytics are cultural, not technical. And I'm willing to bet there's 75% agreement with this statement in the audience that we have here today. And my thinking here is that anyone with more than a couple years of experience in a data role has faced at least a few aspects of what's a really complex and nuanced challenge. The technical side of analytics is fairly easy to implement, but getting a company through the necessary cultural shifts is much less straightforward. And so today I want to talk about one particularly troublesome aspect of the required culture shift: error. And measuring error doesn't have to be complex or particularly time-consuming. So the real challenge with error is instead doing exactly what we're about to do: talk about it. It's a big cultural challenge for a company. And in fact, we just missed a chance to talk about error, didn't we? I made a prediction. I made an estimate. I bet that 75% of the audience would agree with this statement. And these kinds of casual bets happen pretty often throughout a business. Usually they precede some sort of decision-making process. And sometimes they're small and inconsequential, but other times they have 5, 6, or 7-figure implications behind them. Was I right? Was I wrong? How far off was I? If I ever want to improve this estimate that I made, it seems important to have these follow-up conversations. But these conversations aren't exactly sought after and are often completely avoided. No surprise, but being wrong makes people upset. Yet it's precisely when we are wrong that we stand to learn the most. If companies can help all their employees become comfortable with measuring and openly discussing error, those companies stand to learn and adapt much more rapidly than their competitors. So let's dive into this topic. Let's embrace error for the next 30 minutes and realize that error is a chance to improve our learning rate. If we want to be right more often, more quickly, we first need to understand exactly how wrong we were. So let's begin by discussing what is error. And for the sake of this talk, we are going to define error several ways. So we'll first think of error as a measurement of how much something did not meet our expectations, or the difference between what we expected and what we actually observed. And in this sense, error is, well, it's the size of our mistake. But I think we really should avoid that word mistake as much as possible. It just doesn't help facilitate the cultural change that we're trying to initiate here. I prefer to speak of error in terms of expectations and observations. And for this crowd at DataCon LA, it's probably very obvious that when we're talking about expectations and observations, maybe the topic is better labeled as prediction error. But using the term prediction error seems to sort of magically produce unwanted exclusions. It seems to force the discussion towards models and algorithms. And while formal models are definitely one source of predictions at a company, they're certainly not the only source. So while these bullet points, these items are definitely examples of estimates and places we could measure error, I think these are examples of places we can measure error as well. And these are examples of error that might come from someone making a bet in a product team or a people team, a sales team, or a data team, a data warehousing team. But I found that these sorts of examples aren't often thought of when someone says prediction error. So I find that term a little bit limiting. In my mind, error is really prevalent throughout a company, not just in formal models. So while error can certainly be defined as the difference between what we expected and what we observed, perhaps there's other ways to think of error that are maybe more inclusive. So let's try thinking of error as variation from a desired result. And now for some people, people who've been in the data world for a while, they're perhaps recognizing a familiar definition of error here. Because error is not a new fad. It's had its turn in the spotlight before. And for a while, many businesses, especially manufacturing ones, were obsessed with the idea of process improvement, where the goal is to minimize variation from a desired result. And in manufacturing, the goal was to remove defects, also known as error. So back in the mid 80s, Bill Smith, who was an engineer at Motorola, approached process improvement quantitatively and developed a set of techniques and a way of talking about process improvement that became known as Six Sigma. And here the sigma in the name is actually referring to the Greek symbol for standard deviation, which is a measure of variance. And basically processes were to be measured and improved. And the goal was to, well, 99.9997% of the results of that process should be free of defects or errors. And all this brief history lesson is a way to say measuring error is the key to process improvement. And we can definitely think of error as variation from a desired result within a process. But let's also think of error as how much room for improvement is there? Or even how much better can we get at this thing we are doing? And unlike the late 80s and early 90s when Six Sigma reached its peak, engineering and manufacturing teams are not the only teams with quantitative data anymore. These days, every team within a company typically has at least one, often many more, pieces of software that they're using. And more often than not, these tools are helping establish processes, and they're recording data, and they're helping with estimates. So once clean data is collected from these tools, we can examine prediction error, or we can talk about process improvement in really most areas within a company. And to me, this is really exciting news because our final definition of error is an opportunity to learn, a chance to learn and improve. So now that we've framed how we want to think about what error is, let's talk about measuring error. And I previously said that measuring error isn't complex. That statement probably should be refined a bit. Measuring error can be very complex. Certainly, if we're talking about complex multi-class classifier, error evaluation is not perfectly straightforward. But if you find your company building those types of complex models and you're needing to navigate the many, many different ways to evaluate model error, you definitely should have a data science team at that point. But for many of the expectations or bets we place within a business, like this one, simple ways of measuring error can go a long way. We expected to sell 1,000 units of the new product, but we actually sold 670. So a simple measure of error here might be our expected value minus our actually observed value, or 330 units. It's not much, but it's a start, and it's certainly better than not knowing this information. So let's repeat this basic concept with a revenue example. We expected 500K in revenue from this account, but we actually observed 1.5 million. Well, this is fantastic news from a sales and revenue standpoint. And that kind of helps us perhaps see one of the reasons why error might be so unpopular. Because even when you did really well, it just sort of looks and sounds so negative. So for a variety of reasons, not the least of which is sort of solving the sad trombone sound when you exceed expectations and you get a big negative number. The most basic commonly used measure of error might be the absolute value of the expected minus the actual. And this measure affords us, the really handy simplification of just saying, whatever we're doing, we want to minimize error. But I'm sure some of you are still thinking, I'd love to have $1 million more of revenue than I expected. I don't want to call that error at all. And I understand the emotion, but remember the reason that we're setting expectations. It's to help us plan. And just like having too many products can take up costly warehouse space, having $1 million in unexpected sales, well, that might suddenly mean increased support cost or a sudden unexpected need for more headcount. It might even have tax implications. Minimizing error helps us assess, is what you prepared for actually happening? So if you have large amounts of error, even if it's in a direction that you're pretty much pleased with, it bears paying attention to and exploring. And you could probably get amazing results out of business just by making the measurement of absolute error second instinct on every team. But additional context will very likely come in handy. And we can add additional context very simply by incorporating more information about what we observed. So dividing by the observed value gives us a percentage error. This is super simple stuff. We expected 500K in revenue from this account, but we saw 1.5 million. So we have 67% absolute error in our revenue estimation process. And this standardization lets us compare error across domains. So we have 67% absolute error in our revenue estimation, and we have 37% absolute error in our units sold estimate. So if we're trying to minimize error and improve planning, the biggest rock here is probably our sales estimation process. And again, measuring error helps us assess, is what we prepared for actually happening? Because, and this sort of planning and assessment is always ongoing, right? Error is not something we want to measure once. We're going to need to repeatedly measure error. And very often those repeated measures come with a time component. So imagine that we're interested in, sticking with this revenue example, we're interested in an account sales in Q4. And we've done a good job. And for planning purposes, we've been making estimates of what the revenue would be for the past 6 months. And we're recording the actual observed value, and we're calculating absolute percent error. So here we have a plot of our absolute percent error from the past, which is obviously time series data. But let's come back to this after we look at a slightly different example. Other times, and we sort of hinted at this when we were discussing process improvement, the error measures come from calculating error on the same process over and over and over again. And for our demand planning example with our products, we estimated how many units we would sell of a product. And if our company has many products and we make a habit of estimating demand, then we'll have many measures of error represented by this distribution here. So now in both examples, we have distributions of error, and we need to slightly expand our measures to describe these distributions. Fortunately, it's really only a slight modification to the existing measures that we've already looked at, so that we can look at central tendency and distribution of errors. So we can use mean absolute error, mean absolute percent error, median absolute percent error, and not median would obviously be more robust to outliers in our error distribution. And when we're talking about dispersion, we can look at simple range or standard deviation or the interquartile range. So let's go back to that time series example. Well, we can say we have a mean absolute percent error of 30.17 in quarters 2 and 3 in our estimation process. And we had an IQR of 2.25. So 50% of the absolute error measures were in a small 2.25% range. And it's fairly easy to put these numbers to work. So say your revenue estimates for this account for Q4 are as follows: 10,000 in October, then followed by 12,000, followed by 15,000. If you've been averaging 30% error with your estimates so far, in the absence of additional information, it's reasonable to assume each of these estimates will also have about 30% error. And so using that knowledge, we can plan on between roughly 30,000 and 48,000 in total revenue in Q4. And to arrive at this, I simply summed the three lowest estimates based on our 30% error and the three highest estimates, right? But I do want to be very clear. There are much better ways to forecast. But if this is new to you, this is a reasonable first step. Of course, improving future estimates is not the only reason to track error. It also can direct us to additional analyses that might, answer additional questions and help us improve. So with our demand planning data, our errors have a median absolute percent error of 28.4 and a range of 21 to 47. So imagine if we are at a company where 40% demand planning error is really costly. And it's actually kind of hard to imagine where that wouldn't be the case. But this error distribution should prompt additional questions, right? Are certain categories of products on the higher end? What are the costs of this much error to the business? If we know those costs, then we can be much better assessing the relative cost of implementing solutions. So coming back to these measures, this is still very basic stuff, and many of you are probably thinking of numerous other ways to measure error, such as maybe mean squared error or root mean squared error. And again, many more are available. And I'm definitely not arguing that these are the best ways to measure error. There's actually some pretty contentious debate around mean absolute percent error. But the measures here all retain your original units, and they're in percentages, unlike, say, mean squared error. They all have names that explain what is going on, unlike, say, Gini coefficient. And so these attributes make them easier to introduce to a business where analytics is not yet second nature. And that's the vast majority of businesses. And that's sort of the point I'm trying to emphasize here. Keep in mind where this talk began. The challenge here is not really the analyses themselves. The challenge here is getting widespread adoption of an analytics mindset where the importance of tracking error is clear. And we can still learn a lot about how to improve from these simple measures of error, especially if we collect them regularly and examine them often. But maybe technical ease is not, the challenge you're up against. Maybe that's not the struggle you're facing when you're trying to implement this kind of quantitative error tracking at your company. Maybe it just doesn't seem important enough. How do you go about emphasizing the transformative power of error? Well, I've already mentioned that error is a chance to learn and improve. And I want to illustrate just how important error is to learning. So let's talk about machine learning. So, image recognition, image enhancement, self-driving cars, personal assistants and chatbots, recommender systems, email filtering, translation services, fraud detection. These are just a few areas that you're likely using machine learning in your everyday life. And machine learning is already impacting our lives, and that impact is only going to grow and grow. And it turns out that error was an absolutely critical factor to getting us here. So let's think about the historic progress of machine learning. And I started doing research for this talk, and it turns out Wikipedia has a very nice timeline of the history of machine learning. And the extended timeline goes back to 1763. But for an overview, the community thinks the most important events in the history of machine learning can be summarized by these 8 entries. I want to draw your attention to a line here. In the 1980s, the rediscovery of backpropagation causes a resurgence in machine learning research. And this was a pivotal event in the history of machine learning. So what was so special about backpropagation that it merits placement here? Well, it turns out the main benefit of backpropagation has to do with error. And backpropagation is really a class of algorithms that are used within a larger machine learning algorithm. I'm sure many of you are familiar with backprop, but for those that aren't, I can summarize. So our model, this a particular toy model diagrammed here, it produces an output. And we've been calling this output expectations or predictions or y-hats. But we also have our targets, which we've been referring to as observations or actuals. And as we've already discussed, having these two things lets us calculate error. But error calculations like mean absolute error that have been around for several centuries. And the first neural networks were running on mainframes in the 50s. So what was missing? Well, what was missing was a way to utilize error. And backpropagation with gradient descent gave machine learning a way to put error to work. And that is what the rediscovery and application of backprop in the 80s accomplished. Error could now be put to use. And this was effectively the equinox of that AI winter. By figuring out how to make efficient use of error, machine learning began to progress again rapidly. So maybe at this point you're thinking, thanks for the short history lesson, but what does this mean for a business? Well, if we're in agreement that backpropagation of error was a pivotal moment for machine learning, that sort of set the stage for the explosive growth of machine learning that we're seeing now, what can efficient utilization of error do for your business? As I previously sort of mentioned, humans perform predictions all the time. We love doing this. We take in information. We use this ultra complex neural network. It's made mostly out of fat, water, and electricity. And we use it to build expectations about the world, to anticipate what will happen and make decisions. And in some domains, our neural networks are really fast and accurate. But in a business setting, it's often important for our internal network to do things like long-term decision-making after reviewing some complex analyses, or logical and statistical thinking with numbers, considering alternatives, reflective thinking. These disciplines are important to a business's success, but our neural networks aren't really great at them. And there's something else you should know about this particular learning system. It's got some problems in its error function and backpropagation implementation. We've evolved a ton of cognitive and emotional biases that make us pretty unreliable at precisely adjusting our decision-making based on error. And I'm going to venture a guess here, but I'm going to guess that your business is most likely made up of humans making decisions, possibly several hundred humans or thousands of humans. So you've got a group over here taking in inputs and making decisions about engineering. And you've got a group over here, and they're using their neurons to perform marketing. And you've got another group over here taking in inputs and making decisions about accounting. And so you've got billions of cells coming together to perform specialized functions, coming together to form cells to perform specialized functions, coming together to form a thing called a business with a specific function. You see the picture here? Your business is a lot like a complex neural network built entirely on hundreds of smaller, flawed neural networks. Your business model takes in an input. Most likely that input is dollars from your customers. It performs huge amounts of decisions and is trying to maximize some sort of output. And maybe that output is share price, maybe it's societal good. The point is still the same. So now maybe ask yourself, how good a job is your business doing with tracking error and using it to learn and improve. If you're not doing this, then you're missing the part of data that is the most valuable, the ability to learn from data. By measuring and examining error throughout your business, you're benefiting from the same approach that saw machine learning move from an academic curiosity to being used in billions of devices in the hands of billions of people. So it's reasonable to say that analogy was a bit of a stretch for some. So I'll wrap up this section with two statements that are hopefully more straightforward. Like an ML algorithm, your company is a complex function that, well, hopefully you're trying to understand it, improve it, and optimize it. Without measuring error, we have a business that's, doing a bunch of stuff, but few reliable ways to understand what is actually working. Or perhaps even more succinctly, tracking error helps us move from screwing around to a reliable process of learning. So with that, let's move on to our last section. As we begin to wrap up the talk, I thought we should cover some common places where error measurement could be applied within a business. And the theme throughout these is that we want to learn and improve. And to do this, we should be comparing our expectations to what we actually observed. So let's talk about some places businesses can have quantitative expectations. So let's start with marketing. And I want to start with a brand awareness example, because this is truly the entry point to a business, but also because it's commonly a complete unknown, especially at smaller companies. So if this is your company's first time measuring brand awareness, it might be really hard to form an estimate, and that's very understandable. But even in that case, it is probably still valuable to try. So let's walk through a scenario. You've got a decision maker who says, we undertook new brand awareness initiatives this quarter. And as someone who wants to use error to improve the company, maybe you gently inquire for more specifics. Well, what do we expect brand awareness to be after these initiatives? And you're likely going to get very reasonable responses around, well, we aren't really sure, we don't really have enough information, there's lots of factors to consider. And actually, in all these conversations about measuring error, flaws in the data, problems with past tracking efforts, these things will come up as reasons why we can't be quantitative this time. And these should be acknowledged, but they should be used as opportunities to speak either to, well, data quality issues that should become priorities to fix, because after all, data quality issues are another form of error. Or these sorts of concerns should be used to propose additional analyses that could be run to help relieve some of the concern. So reiterate the concern, but help clarify that we need to start being quantitative somewhere if we really want to reliably improve. Similar conversations with a marketing team can develop around efforts to generate impressions or leads, changes to rate metrics, such as lead conversion. Those can also be estimated and tracked. In fact, many companies now use tools that score a lead in some way. And if you're paying for a tool like this and you're not tracking the error rate, you're basically giving the vendor a free pass to just use a coin flip behind the scenes. And as a data scientist who has built algorithms like this, I want to thank you very much for making my job extremely easy. But similar conversations should also be occurring with your sales team. In this example, we see that sometimes it's tempting to avoid even discussing error when an initiative goes well. And I actually had a slide with it. You definitely don't want to become Debbie Downer, and it's really hard not to. It's really hard to avoid that as an analyst. So help use quantitative data to celebrate successes. But bring the discussion back to the fact that error tracking helps us plan. And a primary responsibility of leadership at all companies is to plan. And those plans likely depend on one another. So emphasize that error tracking not only helps their team, but also helps the other teams they work with. And just like with marketing, there's tons of numeric values within a sales team that we care about. The number of deals or trials, other count metrics. attributes of the actual sale itself, like how long it took to close the sale, the order size, all that stuff. Having some estimates of what these values will be in the future is very useful. And it's your best chance, well, your best chance of improving these estimates is by tracking the error around these estimates. And I wanted to be sure to include a bit about people analytics, because this is a really untapped area at a lot of companies. Hands down, people are the most valuable asset at a company. And so if you're planning initiatives, if you're undertaking initiatives to improve your employee experience, don't these efforts deserve error tracking so that we can quickly get better at these things? So in this example conversation, we encounter some resistance based on just wanting to move forward, make forward progress without getting too specific. It's a sort of, let's just try something and check in later conversation that you'll encounter often. And in this case, try and steer the conversation towards what that check-in later means. When we check in, what decisions are we going to need to make? How are we going to make those decisions? Defining expectations for the initiative now will almost certainly make those check-ins much more actionable. Finally, I wanted to conclude with an example of what these conversations could look like at a company that has embraced error tracking and the analytics that go along with it. So in this case, a decision maker undertook a new effort to improve a process and reduce error. The analyst is called on to report the findings. And if any change was seen, does it appear due to chance? It's pretty critical, right? So based on some promising findings from the analysis, the decision maker has implemented a new process or tweaked or refined one that will, improve future planning and actually requires some rethinking of existing plans. So this is exactly what we hope to see. So we've touched on some dialogues and some ways to measure error in a few departments. We can't possibly cover the many places where analysis of error could help a company learn, and we have to wrap up. I'll make these slides available in case these scenarios are useful to anyone. But let's combine what we've learned now. So as you begin trying to steer your company towards more quantitative assessment of their estimations and measuring their error, where should you begin? Well, I'd suggest you begin with trying to help. I hope my example dialogues gave you some ideas, but this effort has to truly come from a place of wanting to help. Approach every analysis, no matter who it's for, no matter the actual findings, as a chance to help the company learn. And the second take home here is that error is simple to measure in most cases. And I know this is not what anyone wants to hear at this conference, but if you have Excel, technically you already have a tool that could do the job. So do yourself a favor and start with simple measures like mean absolute error, mean absolute percent error, interquartile range. Stakeholders will grasp these fairly easily. So you're trying to help and you're keeping things simple, but no matter how cordial your approach, no matter how good a communicator you are, getting others to provide numbers and recording those numbers for later reference is not going to be easy. And that's amazing when you think about it. Despite all the hype around data transforming businesses, despite all the hype around machine learning and predictive analytics, the vast majority of companies still don't make a habit out of rigorously examining simple informative measures like error. And the reason is pretty simple. Humans aren't naturally good at this. So as an analyst, your goal is to help use CPUs and GPUs to complement the decision-making that's coming from this tangle of fat, protein, and water up here in our skulls. And this brings us back to the beginning of the talk. This brings us back to cultural change. Error tracking is part of good, robust analytics. But analytics itself is not just a tool. for it to truly change a business, it needs to be instilled in every decision-making process. Because analytics is a way of thinking. It's a way of approaching problems. And this statement is why the biggest challenges to implementing effective analytics are cultural, not technical. Analysis of error, it's a way of learning what is wrong and then learning how to improve. In a sense, all analytics is a way to explore and with absolute certainty, eventually arrive at new knowledge. It's really a dedication to ceaseless exploration and learning. So thank you very much for your time, and I'm happy to take questions.
All right, thank you, Ryan. We do have some questions, so let me read those out to you.
I'll do my best.
I have one question here. Do you feel there is ever a finite point in optimization, or do you consider this infinite?
Yeah, good question. I don't think we really know the answer to that, right? At some point, optimization does lead to other complex challenges that I think almost in some ways reset what you're trying to accomplish. As you begin to optimize a process, ideally you eventually can automate that process, but I think that introduces a whole new set of questions that you have to tackle as a business. So maybe there's, I'll dodge the question. Maybe there's a sort of a tapering point where you reach a level of optimization where you have to reframe the problem, and then you start tapering down again. So I think that's more in line with how I think of it. Hopefully that helps.
Yeah, I hope it does. I hope it does to whoever asked the question. I have another one here. Says, hi, Ryan, thank you for speaking. Could you tell us how you got interested in error?
Yeah, that's actually pretty easy. One of my first projects as a data scientist after I left, academic research. Well, and I bet there are a lot of analysts and data scientists who will say the same thing. So one of my first projects was forecasting. As soon as the company finds out that you can forecast it, I mean, oh man, the number of forecast requests you get just never ends. So I had to learn. I never worked with time series data. I had worked with MRI data. And I mean, there's a time series component to MRI data in a way, but never, financial time series. So the short answer is I had to start learning how to forecast things like for parts demand, like how many of this part are we going to need? How many of this product are we going to sell? What's our revenue going to be like? And that I had to read a lot about error. And really, as soon as you start getting machine learning, you realize you're learning about error anyway. But my introduction to thinking about error a lot and systematically and quantitatively, I think, was with time series forecasting.
Thank you. I have another question here. Statistical process control was popularized in the 80s and 90s. Why do you think companies in 2020 have yet to adopt this relatively simple form of being data-driven?
Yeah, that's a great question. I really wish I knew the answer to that. I had a figure. I went on Google Trends and I looked up, I tried a couple different search terms. I looked up, so in Google Trends, you can see the history of a search term, right? The popularity of it, essentially. I looked up things like Six Sigma, statistical process control, and I also added, data science, big data, Salesforce, and some of these other pieces of software that are really ubiquitous at a business now. And you can see that, statistical process control and Six Sigma, they're just, Google Trends goes back to like 2004, or I think. And you can see them just declining and hitting a floor well before these new things like data science and Salesforce, and before those were ramping up. I think they were just sort of two ships passing in the night, very related, very similar in what they're trying to accomplish. But I think one started to die out because it was too applied to engineering and manufacturing. And people at tech startups who weren't building hardware, building software, we we have a tendency to reinvent the wheel, don't we? So I think that's really the answer. I really would love to dive more into the history of why that occurred.
All right. Well, thank you, Ryan, for the presentation. It was great. Thanks for answering the questions. We are at the end of this session, but for everyone else, if you have any other questions or you'd like to continue the discussion, feel free to do this in the Who app. You can use chat, you can use Q&A. Ryan, obviously, if you would be so gracious to check out the Q&A, if there's any other questions, would be very appreciated if you do answer those. And that's it. The next sessions, I think, start at 3:30. So see you everyone in one of those sessions. And again, thanks a lot.
Thanks for attending, everyone.
Right.
Bye.
See you, everyone.